All right, so in this video, we're going to take a look at the 3U factoring review again. Okay, we're going to look at questions 16 to 20 with special note on question 19, which is a little bit tough. So without further ado, let's do number 16. So our question for 16 is 9x squared plus 1. One might think, okay, I'm going to try 3x plus 1 squared. But as we've alluded to in the last few days, you should always be checking to see whether or not what you've written as an answer actually expands back to the original question. And it turns out if I wrote down what I wrote down, it would not expand to give me the original back. This particular question actually does not factor. So don't mix this up. DNF for does not factor. Don't mix this up with a question that looks like 9x squared minus 1. That is a difference of squares, and that can be factored. But the one on the left, or the original number 16, cannot be factored. So that's that. Don't mix that up. Okay. 17. Question 17 is 6x squared minus 28x minus 10. So some of you may choose to go multiply to negative 60 and add to negative 28. That could work, or would work actually. But there's something that we can do from the beginning of this question to make our lives a little bit easier. And that is, as we discussed in grade 10 a bunch, always common factor first. So there's a common factor in these three terms of 2. And I can remove it, and when I remove it, I'm gonna get left with this. Okay, so that's common factoring here. Okay, and then from here, now you can find the multiples, or the conditions, the factors that attribute to a multiplication of negative 15 and negative 14 for the addition. Okay, and so when I go to check that, it's going to be negative 15 and 1. Be careful. Don't just think, oh, I'm good. I'm going to write that as my, this is not a simple trinomial, right? It's complex because of the a value. So you're stuck having to use decomposition. So we're going to get 3x squared minus 15x plus 1x minus 5. Okay, and we're going to close the bracket and then factor the inside by grouping. Okay, so 2 across the first two terms, 3x is what's in common, and we're going to be left with x minus 5. And then on the other side, we're going to be left with just a plus 1. Like I can remove a plus 1 from both of those two things. And then x minus 5 again. That should be your clue. Again, when we're doing questions involving decomposition and complex trinomials, that's your clue that the question is correct, or that you've done your work correct. And now you can remove that yellow piece across the two terms that still exist. So we're going to be left with 2x minus 5 times 3x plus 1. That should be your answer for 17. Okay, so number 18. Number 18 is x to the power of 4 minus 64. Okay, this to me looks like a difference of squares. Okay, although it doesn't have a square in it, it has a power of 4, and you can still square root x to the power of 4. Okay, turns out when you square root x to the power of 4, it turns into x squared. And when you square root 64, it's 8. And we know with difference of squares, we're going to write it twice. And the signs are going to be opposite. That should be your answer for that question. I'm just going to scroll down because number 19 is going to require a little bit more work. So we're going to start on a new page here. So 19 is quite a tricky one. Got me for a bit of time. So it's m to the power of 4 plus 3m squared plus 4. Okay, it was quite tricky to actually find somewhere that could show me how to tackle this question. And when I found it, the steps involved was a minor manipulation of the question. And you recall back to when we completed the square, we were able to add and subtract a particular term to an equation without changing it, because it would have been a zero pair. So what we're going to do here is I'm going to add an m squared and take away an m squared from this equation. This is the trick to the question. Okay, when I do that, I can combine that m squared with the 3m squareds that are already in the question, and it's going to turn into m4 plus 4m squared plus 4, and then you're still going to have this leftover minus m squared on the end. Okay, now when I look at the first 3 terms individually, that is a perfect square trinomial, and we know how to deal with that. Okay, so we're going to square root the first and square root the last and take the sign that's on b. So it's m squared and 2, that would be the square root of the first and square root of the last, and take the sign from b. Okay, that's a perfect square trinomial, and it's squared. Okay, because there would have been 2 of them to create the equation above. Now don't forget, you still got that minus m squared sitting there, so we're going to go minus m squared. Once you've arrived at this stage can be defined by a difference of squares. Okay, and so I can square root the first, square root the last, write it twice with opposite signs. That's difference of squares, right? So we're going to get m squared plus 2 minus m. Sorry, it's a different question. Okay, and then we're going to have m squared plus 2 plus m. Okay, that's your difference of squares. Okay, just a little bit more complicated than usual. Okay, there's actually nothing to be combined in here, so what we're going to do is rewrite it in descending order, and that should be the answer that you end up seeing on your sheet. So we're going to see m squared minus m plus 2. That's going to be multiplied against m squared plus m plus 2. Okay, and that should be the answer that you end up seeing. Okay, tougher question there. Okay, minor manipulation from the beginning, that's the key to that question. Okay, question 20. We're going to have negative 9x squared minus y to the power of 4. Okay, on the inside of the brackets is what we see as being a difference of squares there, right? So we're just going to factor that as difference of squares. Okay, so I'm just going to go, okay, negatives out front, square root the first, square root the last, write it twice, use opposite signs. 3x is the square root of 9x squared. Y squared is the square root of y to the power of 4. Write it twice. Opposite signs. Question over. Okay, so that's 16 to 20.